All right, hello there, grade algebra students. Mr. Zacek here. We are looking at our last unit, Unit 14, which is on probability. And today we're going to be talking about permutations and factorials. So to begin, we just have kind of a setup here. Mrs. Smith, the teacher, has announced that she will call on 3 students of her class, John, Emily, and Tanner, to give oral reports today. How many possible ways are there for Mrs. Smith to choose the order in which these students will give their speech? So the thing that we see from this scenario is it's a scenario where the order matters, okay? Because if John goes first, he's not going to go second, all right? And when we do that, we're going to use a permutation. I just have to get my board aligned here. Excuse me, as I do that. Okay, sorry about that. So, a permutation is an arrangement of objects in some specific order. Order matters. So, suppose there are 10 people getting a line to buy tickets to a movie. How many ways could they be arranged in a straight line? Well, when we have that, so how many people do you have for the first one? Well, you could have 10 options. And now you take away one, and what do you have left? Well, there's 9 options. And then there are 8 options. And now 3 people have already been lined up, so 7 people are left. Now 6 people are left. Now 5 people are left. Now 4 people are left. Now 3 people are left. Now 2 people are left. Now 1 person is left. And we want to multiply all of those together. So when we multiply all of those together, we come out with there are 3,628,800 ways that those people could get in line. And we represent that using the factorial symbol. So as we look at this here, 3 factorial is 3 times 2 times 1. When you do that, you get 6. 5 factorial, 5 times 4 times 3 times 2 times 1 is, that comes out to be, check it, 120. Okay, I think you get the next one. And the last one here, 8 factorial divided by 3 factorial, so it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1. Now what happens in this, you go and those cancel each other out, they divide, and so it just becomes 8 times 7 times 6 times 5 times 4, which equals 6,720. Okay. So to put a factorial in the calculator, you can push the math button. If you get the left arrow, number 4, you'll see that exclamation point there. You can use that. And then for any natural number n, the permutation of n objects taking n at a time can be represented as, so if we have n, p, n, so this is like 10 people in a line. What this comes out to be is it's n factorial. Okay, so so example, 5p5. It's going to be 5 times 4 times 3 times 2 times 1. Okay, so as we look at this, suppose there are 8 basketball players on a team. The coach has 5 players on the court and 3 to be seated on the bench. And how many ways can the 3 of them be seated on the bench? All right, so the coach has 5 players on the court and 3 seated on the bench. So he's got 8 players in total. So our n is 8, permutation, and we're only going to choose 3. And how many ways can 3 of them be seated on the bench? So here's what you do. You're going to start with 8, and now this 3 tells you you're going to go down 3. So 8 times 7 times 6, which comes out to be 8 times 7 times 6, 336. So there are 336 ways, quite a few possible arrangements that you have. So do you see what this is? This is the total, and this is the number you want. Okay, of the total, how many are you going to arrange? So in this case, we're arranging 3. So that means here's 1, here's 2, here's 3. So you just go down by 1. Okay. So find the number of permutations of the letters of the word math. Well, how many letters are there? There's 4, P, 4. Okay. So we can put them in 4 ways. So you got 4 times 3 times 2 times 1. So we have 4 times 3 times 2 times 1. Comes out to be 24. All right. How many ways can first, second, and third place be awarded in a contest of 10 people? So you got 10 people. How many places are we going to be awarding? 3. So it's 10, 9 times 8. So you go down 3. There's the first one, there's the second, there's the third. So 10 times 9 times 8 is 720. So you got 720 options. Okay, so for any numbers n and r where r is less than or equal to n, the number of permutations of an object taken r times is found by, so this is n, p, r. And the way that you write this out is you write it's n factorial over n minus r factorial. Okay. So what happens if we, use our example like 5p3, what happens here is you have, so 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial. So you have 5 times 4 times 3 times 2 times 1 over 2 times 1. What happens? The 2 times 1 cancel out, so it's just 5 times 4 times 3. So what I showed you earlier was just kind of a shortcut, as this 3 tells you how many times to go down. Okay, so we're going to kind of use the shortcut here. 9p4, that's a 9, there's our first one, 8 is our second one, 7 is our third one, and 6 is our fourth one. We stop there because that's a 4. 5p2, 5 times 4. 6p3, 6 times 5 times 4. Okay. Again, you can use your calculator. It'll do it for you. All right. But that's just, kind of a little bit of a shortcut here is to look at that number. And this number 4 tells you how many you need. So you start at whatever 9 is, and then you go down 1 4 times. All right. So there are 12 horses in a race. Winning horses are those that cross the finish line in first, second, and third place, commonly called win, place, and show. How many possible winning orders are there for a race with 12 horses? So same type of thing. So you have 12p3. So that's 12 times 11 times 10. All right, you got 12 options for the first one. Once that's taken, there's 11 left. Then there's 10 left after that. Okay, so there are 1,320 orders that could be. Crazy. Okay, how many 3-letter permutations can be formed from the letters of angle? So angle has 1, 2, 3, 4, 5. So you've got 5 letters. You want to know how many 3-letter options? Well, you got 5 for the first one, you got 4 options for the second one, you got 3 options for the third one. So 5 times 4 times 3, you come up with 60. Okay. So now we have A lottery ticket contains a 4-digit number. How many possible 4-digit numbers are there when a digit may appear only once in the number? A digit may appear more than once in the number. All right, so when you have this, how many digits are there? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 digits. That's something that you want to keep in mind. 10 digits. So a lottery ticket contains a 4-digit number. So we got to have 1, 2, 3, 4. May appear only once in the number. So how many options do you have for the first number? Well, you have 10, but you can't repeat. So now you've already used one, so now you have 9 options, then you have 8 options, and then you have 7 options. So when we multiply those together, we get 10 times 9 times 8 times 7, 5,040. All right. A digit may appear more than once in a number. Okay, well, if you can repeat the digit, you got 10, but now how many options do you have for your second lottery number? Well, now you still have 10. You still have 10, you still have 10. So when you multiply those together, you have 10,000 options. So with repetition, you get a lot more options, all right? And that's what we get into here in this next thing. Permutations with repetition. Okay. How many different 4-letter words can be formed from the letters com? You got 4 letters, so you have 4. You can repeat a letter, 4, 4, and 4. So 4 times 4 times 4, 256. Okay. So they can be repeated there. All right, let's skip this one. So now what happens is when you have the things that repeat, you want to put them underneath that. So in this example here, how many different words can be formed from? We have 1, 2, 3, 4, 5. So we do 5 factorial over what repeats? Well, D is in there 3 times, so that's 3 factorial. So we do 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. These cancel each other out. That's really just 5 times 4, or 20 possible options. Okay, back, just had to check on something. All right, now divided, we have 1, 2, 3, 4, 5, 6. We've got 7, so we do 7 factorial. Now notice here, how many D's do we have? 1, 2, 3. So for that, we're going to put 3 factorial, but we also have 2 I's, so we're going to put 2 factorial here. So this becomes 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So what happens here is we're going to get some things that are going to cancel out. And now I've got 2. 2 will go into 4 2 times. So this becomes 7 times 6 times 5 times 2, 420. Okay. We're just going to do one more. Bookkeeper. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 factorial. What repeats? 2 factorial, 2 O's, 2 K's, 2 factorial, 3 E's, 3 factorial. So we've got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, over 2 times 1 times 2 times 1 times 3 times 2 times 1. And what can we reduce? Those cancel each other out. 2 goes into 4 2 times. 2 goes into that 2. All of that reduces to 1. So it just becomes 10 times 9 times 8 times 7 times 6 times 5, which is 151,200. 200. Okay, so with permutations, the thing to keep in mind is the order matters. All right, good luck with that.